Okay. We start with, and people did pretty well on this quiz, on the whole. Everybody pretty much had the first one, but we gotta be careful. First, we copy down what we have, and this is it. Okay? Some people put parentheses into this thing. There's no parentheses in the expression, so when you write it out, you're not going to put parentheses in. For example, you certainly wouldn't put parentheses around x cubed minus 6. Why? Because of order of operations. 6 is multiplied by x squared. It's not subtracted from x cubed. So after you multiply 6 by x squared, then you're going to subtract it from x cubed. And after you multiply 5 by x, you're going to add it to whatever you got here, and so forth, okay? And you're not going to group the x minus 15 because multiplication comes before addition or subtraction. So we have to do multiplications first. We have to do exponents before that. So you wouldn't do quantity 6x and square it. You have to square the x before you multiply by 6. Okay, so this gives us then p of 4. It's then going to be 4 cubed minus 6 times 4 squared plus 5 times 4 minus 15. Notice I'm squaring the 4, not multiplying the 4 by the 6 before I square it. Okay, that's 64 minus 96 plus 20 minus 15, and check my arithmetic. I do it quickly in my head, and you never know what's going on in my head, neither do I. Okay, so now you have a total of negative 96 and negative 15 and 64 and 20. And of course you have the associative law and commutative law of addition. You put those together so you can write this as 64 plus 20 minus 96 minus 15, and that's going to be 84 minus 111, and that's going to be negative 27. Okay? Now I did that quickly because it's very straightforward. Almost everybody did it right unless you messed up the order of operations, which you really don't want to do. Okay? Now everybody pretty much did this one, got the right answer. But you know what I really don't want to see? Not that I'm going to penalize it on a test, but I really don't want to see it. I don't want to see this. Because at least one person did this on the next problem, and as a result didn't get it right. Okay? Because it gets a little confusing if you've got more than binomials. If you've got more than two quantities here, it's fairly easy to confuse those. Erase the whole thing and rewrite it. So I don't want you to do that. That's not a rule. That's a shortcut. Now, if you understand why the shortcut works and don't ever mess it up, okay. But if you use that shortcut and mess it up, I'm not going to be sympathetic with grading, okay? If you do the distributive law and mess it up, then I'll be sympathetic, okay? At least more sympathetic. You get more partial credit. You're not getting any partial credit if you do that thing I just showed you, okay? So if you do it and get it right, I'll accept it, although I won't really like it, but it's not going to affect your grade, okay? If you do that and mess it up, it's very likely to affect your grade because you're not getting partial credit. Fair enough? Now, fair or not, that's what it is, okay? And I'm doing it only because I want you to learn this stuff right. Okay, so we have x minus 4 times x plus 6. I've done it this way. You've seen me do it this way if you were in class or checked the videos, okay? Pick it up right now. This, by the distributive law, is x times x plus 6 minus 4 times x plus 6. And this is the distributive law because x minus 4 times whatever is x times whatever minus 4 times whatever. That's the way the law works. It's not this, this, and this, and this. although nobody messed it up on this one, okay, because it's binomial. Okay, but I'll show you how it's easy to mess it up on the other one, okay? Now, what's x times x plus 6? Well, you use a distributive law again. That's x times x plus x times 6. Just writing it out as simply as possible. And then it's minus 4 times x minus 4 times 6. It's the distributive law again. Now we can write x times x as x squared, x times 6 as 6x, minus 4 times x is just minus 4x, and 4 times 6 is 24, so we have minus 24. And now we have x squared plus 2x minus 24. Distributive law, not little loops, okay? Now, a lot of people did little loops on the next problem and got it right, but some people got it wrong too, okay? You're gonna do little loops, make sure you got it right. It's the bottom line. And I really think it's better for you if you understand application of the distributive law, because there are expressions that can confuse you very easily if you're doing little loops, okay? You're safer using the distributive law. Now, in your, if you take a Math 161 class with somebody else that puts time limits on tests, and time limits are valid, tests with no time limits are valid, the test will be a little different. Okay? So whoever you take, whoever you get for that class when you get to it, might well allow the little loops, might even encourage them, okay? Don't argue with me, but in my class, you do the distributive law. And I don't think anybody's going to tell me that's a bad idea. They just say, well, yeah, but I prefer to do it this way because it's quick and we can do other things. So, and, there's a wide variety of what's valid. Okay, so this is what? So I'm going to need a little room here. That's x times x squared minus x plus 6 plus 5 times x squared minus x plus 6. And that's why the distributive law, I don't have room to write that out, but that's why we do this. This times this plus this times this. Okay, well, the rest is very easy. That equals x times x squared minus x times x plus x times 6. So I'm going to write it as plus x times x squared minus x times negative x plus x times negative x plus x times 6 plus 5 times x squared plus 5 times negative x plus 5 times 6. Notice I've got a plus 5 here, and I'm going to write it out as plus 5 times this, plus 5 times this, plus 5 times this. Then the negative will take care of themselves in the next step. Now, if you really want to say, okay, 5 times negative x is negative 5x, and kind of skip this, just be sure you do it right. Okay? Not writing it out literally, and you make a mistake on it, you're going to get less partial credit. Okay? I wouldn't penalize that heavily, but probably cost you a point if you did it wrong, or at least a point more than it would cost you if you did it right. Okay. X times x squared is x cubed. X times x is negative x squared. X times 6 is 6x. 5 times x squared is 5x squared. 5 times negative x is negative 5x. And 5 times 6 is 30. And now we only have one x cubed term. And I'm kind of shortcutting this. I'm not going to rearrange it and everything, but I could. And a negative x squared and a 5x squared gives you a 4x squared. 6x and negative 5x gives you plus and x plus 30. And there it is. Okay? Very easy. Not as quick as doing the little loops, because there's a little more writing, but you're talking about maybe 15 seconds more writing. If you understand it, you can easily write this, then this, then this. That's maybe 30 seconds. Okay? Depending on how fast you write. If you write very slowly and deliberately, it might take you a minute or more. It's not going to take you a huge amount of time. So unless you have dozens of these to do, you won't on a test. It's well worth writing it out completely to remind yourself of what's going on. Okay? Now, on these last two, x squared plus 4, we're really only interested in the highest power we have here. So we're just going to write that as x squared plus some other stuff. Doesn't matter what else is in here as long as it's lower powers. Take the highest power out of here, put it here, and everything else is irrelevant to the question of what's the highest power of x going to be when you multiply these out. Okay? So, the highest power of x is the degree. All we're interested in right now is the degree. We don't want to multiply all this out. You know, we've got to cube this and, you know, it's going to be a mess. However, when you cube this, you know that if you multiply this by this, you're going to be multiplying this x squared by this x. That's going to be the first term you get from the multiplication. So if I group it like this, and like this, this equals x squared times x cubed plus a bunch of other stuff. And this set of parentheses is x squared. Well, x squared plus a bunch of other stuff. Well, that means that this is x to the fifth. I can't do color-coded, can I? Well, I try, but x to the fifth plus a bunch of other stuff times x squared. It's yeah, times a bunch of other stuff. Which equals what? We're going to have x to the fifth times x squared plus a bunch of other stuff that's x to the seventh plus a bunch of other stuff. Okay? And the other stuff doesn't matter in any of these cases. We're just selecting out the highest power you get when you do, let's say, this times one of your x plus 6's, okay? And then the other x plus 6 times x plus 6, giving you 3 of these. Well, what you can then see is, in this term, your highest power is going to be an x squared. Now, I haven't grouped it this way because I grouped it in the quickest way, but if you do x plus 6 cubed, if you think about it, if you expand anything like this, you're going to see you get an x cubed out of this, right? And that's some other stuff of lower power. So this is going to give you, highest power you're going to get out of this is x squared. The highest power you're going to get out of this is x cubed. And what I wrote is incorrect. It's not x squared times x cubed, it's x squared times x, which gives you an x cubed. Okay. I was thinking the other grouping, and now that I go back and check it, I see it's not what I wrote down. Okay, let's see what it is. This should be x squared times x. There's no x cubed here, is there? Now, if I grouped it otherwise, it would be, but that's not how I grouped it. Okay, so I got x squared times x, and what's x squared times x? That's x cubed. So now I've got x cubed plus times x squared, because when I multiply this by this, I get the x cubed times x squared. Here I get the x to the fifth. So I'm sorry, I messed that up. In my head, I was getting an x cubed from here and not grouping it the way it is, so I wrote it down incorrectly. The logic is correct, but that shouldn't have been an x cubed. That should just be an x. And if you follow that, this is what you end up with. Okay, well, let's see how it works out over here. Let me try not to mess this one up. Okay. If I do x minus 6 cubed, then I'm going to have an x minus 6, an x minus 6, and an x minus 6. Okay? I don't want to write out all these x minus 6's because for them to be consistent, I'd have to write out 4 of these. But we have to understand that if I cube x minus 6, and if you do a few of these, you'll see how it works. You're going to get an x cubed and a bunch of other stuff. That makes sense? Because again, you got x minus 6 times x minus 6, which would itself give you an x squared. And then that's times another x minus 6, which then gives you an x squared and an x minus 6, or an x cubed. You want to write it out, at least for smaller powers. Over here, you're going to have an x squared plus a bunch of stuff to the 4th power, right? And I'm going to write that out because it's not as obvious. Okay, you get x squared plus a bunch of stuff. And a bunch of stuff, in this case, is a 4x plus 14. But we're not interested in the lower powers. We're only interested in the highest power because that's what gives you the degree. And of course, you have to know that the degree of a polynomial is the highest power, the highest exponent that you find when you write out that polynomial. And of course, that means the way to learn that is by doing the homework, because it's very clear in the homework. Okay? And most of you did. You did quite well in the homework. Okay. And most of you did pretty well or quite well on the quiz. So I'm pretty pleased with what I see, but I still want to see it completely right. What's the initial population? Because you're heading into pre-calculus. You can't have this stuff give you trouble when you get to pre-calculus, so you'll never understand it. Okay? So we're really trying to achieve a high level of understanding, the highest we can. Okay, so this is x cubed plus a bunch of stuff. If you do x squared plus a bunch of stuff times another x squared times a bunch of stuff, you're going to get an x to the 4th, right? And then times another x squared plus a bunch of stuff, you're going to have an x to the 4th times that x squared, you're going to get an x to the 6th. And then another x squared, because we're going to have 4 of them, plus a bunch of stuff times the x to the 6th plus a bunch of stuff gives you an x to the 8th. plus a bunch of stuff. So it's x to the 8th plus a bunch of stuff. Now, you can just say, well, that's x squared plus a bunch of stuff to the 4th, so x squared to the 4th is x to the 8th. But you want to see it as completely as you can. If that's all you see, it'll be okay as long as you remember it. But if you remember why, you got this times this times this times this, and every one of these has an x squared, and there are 4 of them. You see why you get the x to the 8th, and you don't tend to forget it. Otherwise, it's very easy to confuse the rules. Okay, well, in any case, so if you do the distributive law here, you are going to get an x cubed times x to the 8th, because remember, this all comes back to the distributive law. Sorry, x to the 3rd plus x times x to the 8th, that's an x to the 11th plus a bunch of stuff. So here, you have degree 11. Here you have degree 5. Again, the question is, what's the highest power of x that we can get when we expand all this, right? We're not interested in expanding it. I'm not interested in expanding this. It's going to be pretty long, a lot of writing, a lot of opportunity to make stupid errors, which I'm prone to, okay? Or arithmetic errors. In your case, those aren't stupid errors, those are just arithmetic errors. In my case, it's stupid, I should get them right. And I'm real good at arithmetic if I'm careful enough, okay? So there's no excuse except sometimes I'm thinking about what I'm going to say rather than what I do. That's not an excuse. That's how you do degree. Make sense? Okay, good.